and some basic concepts and some basic things related to electric field. So in the beginning, electric field is simply a region around a charge in which any other charge experiences a force of attraction or repulsion due to some other charge. So electric field is simply a region around a charge. Let's say if I have a positive charge, then this positive charge will have a region around it. It is having a region around it. In this particular region, this electric field obviously extend up to infinity, or although its strength will decrease or die out by the time it reaches to infinity, right? So it will have maximum influence in its nearby regions. So if I have a positive charge, then I can simply state that this positive charge will have an influence on any other charge when it is brought, or when that is brought near this positive charge. If I bring a negative charge in this region, then this negative charge will get attracted towards this positive charge. So this way, this positive charge is reducing its influence or its effect on this negative charge. So each charge has a region around it in which it can show its influence in the form of attraction or repulsion on some other charges. So this complete region is called the electric field of this positive, capital Q positive charge, right? So if I want to define, or if I want to quantify the value of electric field, for example, as I told you that the electric field will be more stronger as near to this charge Q as compared to the value of electric field or the intensity of electric field at this point B. Intensity of electric field at A is higher than the intensity at point B, which is farther. So if I want to quantify electric field, then I'll use the concept of electric field intensity. Intensity word is not always used. In fact, guys may ask you to simply calculate electric field. This automatically signifies that you have to find the electric field intensity. Irrespective of the fact he is asking you to find intensity or not, if he is asking you to find electric field, means you have to find the intensity of electric field. So electric field intensity is a vector quantity denoted by E vector. So electric field intensity is simply the force acting on a unit positive test charge. In mathematical form, electric field intensity or the strength of electric field is denoted by E vector, and that is equal to F vector upon Q naught, where Q naught tends to 0. This Q naught is actually a test charge. Now what do I mean by this test charge? Simply, test charge is such a hypothetical charge. It really do not exist. Such a charge can never exist. Test charge is such a hypothetical charge which do not affect the configuration of nearby charges. So test charge is such a hypothetical charge which do not affect the configuration of nearby charges which are present near to this charge q naught. So if, in other words, I can say that if I have to find electric field due to any configuration, then I just want, or I should just find the force on +1 coulomb charge. For example, we'll be finding electric field due to various charge configurations. We have to find electric field due to various charge configurations. First, electric field due to a point charge. If I have to find electric field due to a point charge at any point, let's say if I have a positive charge plus q and I have to find electric field at this point p, which is at distance r from this point charge plus q, then electric field at p will be simply k. It is simply the force between this plus q and a +1 coulomb charge, +1 coulomb hypothetical test charge. So the force between this q and +1 will be kq into 1 by r square. So the electric field at this point p is simply kq by r square. If I talk of the vector form of this electric field, then that is also very simple. This will be kq by r cube into r vector, where r vector is simply let's say this is positive charge plus q kept at origin, and r vector is the position of this point p. So I can easily find in vector form the electric field at this point p, which is in the radial direction along the line joining plus q and point p. I can easily see that I told you that E vector is equal to F vector upon Q naught. Q naught was a hypothetical charge. If I put the value of that Q naught to be equal to +1 coulomb, then I can simply see that the electric field is simply equal to force vector when Q naught is 1 coulomb, +1 coulomb. So I can say that the electric field is simply the force acting on the +1 charge or +1 coulomb. So this was the electric field due to a point charge in vector form. Or if I want to find simply the magnitude of electric field, then I can simply find it by using the rule that is kq by r square, where r is the distance of the point P at which electric field has to be found. Now let me find electric field due to ring. If I want to find electric field due to ring, then let me divide the problem in 3 cases. If I have to find electric field at center, I'm given a ring having charge q, having center O, then electric field at O will be 0, because this charge, this TQ charge, will exert force on this +1 coulomb down in downward direction. This TQ charge will push it upward, these two will get cancelled. This TQ charge will push it here, this TQ charge will push it there, these two will get cancelled. So that way all the forces will get cancelled and we'll get electric field at O to be 0. So that is a simple thing. We have already done this kind of question previously. Let's find the value of electric field at axis. If I have to find the electric field on any point which is present on the axis of the ring. So this is the ring having charge q and radius r. Let's say this is a point P at distance x from the center of ring, and if I have to find the electric field at this point, then what will I do is I'll simply divide the ring in many small charges, which are, let's say, dq. So this is a charge dq, that is another charge dq, and at this point I'll put a +1 coulomb charge. This dq will exert a force on this +1. This dq will exert a force on this 1 coulomb. This dq will try to exert the force on this +1 coulomb in this direction. Let's say that force is df, and the upper dq will also exert some force, in fact the same force, on this +1. I can easily see that this angle is theta. If this is theta and this is theta, then this will also be theta. I can easily see that this df can be broken into two parts. This df can be broken into two parts. This is df cos theta. This is df sin theta. Same way, this df can be broken into two parts. This is df cos theta. This is df sin theta. So I have taken just two charges that are diametrically opposite to each other. This dq and this dq, these two are the charges that are diametrically opposite to each other, and I found just the electric field. I just found electric field at this +1 coulomb, which is in this direction. You can say the force on this +1 coulomb is in this direction, and force on this +1 coulomb due to this dq is in this direction. Then I resolved this df force in horizontal and vertical component, this df force in horizontal and vertical component. These two vertical components will get cancelled. Same way, I can say that I'll be having couple of dq charges that will be diametrically opposite, and the vertical components df sin theta of all the pair of charges will get cancelled, and df cos theta will get added up. So what I have to do is I have to simply integrate df cos theta to get the force in x direction. So the value of this df will be k dq, other charge is 1, and by this distance square. This distance is x square plus r square root and square. This is x square plus r square root. And now I have to put cos theta also. You can easily see that this cos theta will be constant. This cos theta will always be x upon this x square plus r square for any dq. If you talk of this dq, you'll get same theta. If you talk of this dq, you'll get same theta. So this cos theta is also a constant quantity, which is x upon x square plus r square under root. So if I have to integrate it to find the force in x direction, which will also be the electric field, because force on +1 is simply the electric field. So what I'll get is kx by x square plus r square to the power 3 by 2, and the integration of dq. Integration of dq will be simply q. So kqx by x square plus r square to the power 3 by 2. So this is the electric field, and this will be in I cap direction if the charge is positive charge, and if this is negative charge, then this electric field will be in minus I cap direction, because in case the ring is having minus charge, then this +1 coulomb present on axis will get attracted towards the ring. So this way we can easily find the electric field on any point, at any point present on the axis of the ring. Now what I'm going to do is, in case 3, I'm going to find electric field at center of an arc. Let's say I'm given with an arc like this. This is an arc, and this arc is making an angle phi at center. The total angle is phi. What I'm going to do is, I'm going to simply draw a bisector of this angle phi. I have to find electric field at this point O, which is the center of the uh, arc. What I'll do here in this case is, I'll move to some angle theta, and I'll just take an elemental angle d theta. At angle theta I moved and I took this d theta. This length will be rd theta. This arc is having a total charge q. The radius of this arc is r. Then if I want to find the charge dq in rd theta length, then dq will be q phi. Let's say this q charge is present in angle phi, then d theta will have this amount of charge. This dq charge which is present in this small uh, d theta angle, this dq charge will exert a force on this +1 coulomb kept here in this direction. The force due to this dq will be in this direction, df. Same way I'll get another dq which will exert force on this +1 in this direction. So these are the two df forces. I took this angle to be theta. This will be theta. This will be theta. I can easily see that this df will have a sine theta component in this direction. This df will have a component df sin theta in this direction. These two will get cancelled, and 2df cos theta will get integrated to give me the force in y direction, and this net force in y direction will be the simply electric field, which will be 2 df will be k small charge dq, other charge 1 divided by distance, which is r square, k q1 q2 by r square. This is force df. Now cos theta and its integration from angle -phi/2 to +phi/2. Why I have chosen this -phi/2 to +phi/2 is, in this direction if I move, this is -phi/2 angle. In this direction up to this point, the angle will be +phi/2. So the limit is -phi/2 to +phi/2. Now what I have to do is, I have to simply put the value of dq and then integrate the expression. So here 2k by r square is constant, cos theta into dq is q by phi into d theta minus phi/2 to +phi/2. So 2kq by phi r square. The integration of cos theta will be sin theta minus phi/2 to +phi/2. So one thing you have to remember here, one mistake that you can do is, If you are taking limit minus 5 by 2 to plus 5 by 2, then you need not take this 2. If you are taking minus 5 by 2 to plus 5 by 2 the limit, then you will have to omit this 2, because by including this 2 you have already included this the force of this segment present on the left hand side. So either you put this 2 here, or you simply put the limit minus 5 by 2 to plus 5 by 2. So if I am not putting this 2, I'll put the limit minus 5 by 2 to plus 5 by 2, and if I am putting this 2 with me, then I'll simply put the limit from 0 to 5 by 2. Here also the limit from 0 to 5 by 2. Here also the limit from 0 to 5 by 2. So this way what I'll get is 2kq by phi r square and sine 5 by 2 minus sine 0, which is 0. So my final answer is 2kq sine phi by 2 upon phi r square. This is the electric field due to this arc at its center. The direction of this electric field will be along bisector of arc. The direction of this electric field will be simply along the angle bisector of the arc. Like say if this is the arc, this is positive charge, then what I'll do is I'll simply keep plus 1 coulomb here. These positive charges will repel this plus 1 coulomb in this direction. So the electric field will be in this direction if the charge on the ring is or the arc is positive. If the charge on the arc is negative, then the force on this plus 1 coulomb at center will be towards the arc. So in this case the electric field will be in this direction. So this way we have learned the electric field due to point charge, electric field due to ring at its center at axis, and electric field due to arc at its center.